Hello everyone, welcome back to another video on crack concepts, and in this video we will be discussing 5 important topics that you should definitely revise before your SQL interview. This is the most asked video on my channel, so let's begin with it. So CTE, which is common table expression, it is a temporary named result set that you can reference with a select, insert, update or delete statement. So it's basically a temporary result set. This is not permanent. When you create it, it will stay temporarily, and then you can use it in your select or insert or update or delete statement. The syntax is something like this. You write with keyword and then you will give a name to it with whatever name you want to give to your CTE as, and then you will give a query, and after that it will be followed with a select statement or insert or update or delete or any statement like that. First I'll show you all my table, which is select star from employees. So this has employee ID, department ID, product ID, quantity and sales. Now I'll show you a very basic example of CTE. So I'll write with over here, then I'll give a name to it, which is CTE1 as, and whatever query you want. Select IMP ID, department ID from employees. So this is your query, and this will be inside CTE, okay? And then after that it will be followed, there will be no semicolon or anything over here, okay? It will directly be followed by a select statement or insert or whatever statement you want to write, but here right now I'm using select statement. So select star from CTE. So what happens here is, this is a temporary result set. If you simply just execute this, it will throw an error. CTE1 doesn't exist, because this will go hand in hand. This will together only be executed. CTE1 is executed or is created every time when we execute. So it has to be executed every single time because it's temporary. Now I'll give you an example. I'll name it CTE2, and now inside in my query I will write select average sales from employees group by department ID. So what is this query doing? This will give me average sales group by department ID. So this will give me average sale for each department ID. I'll also write department ID over here. First I will write over department ID. Okay. And then I write like something like this. Select star, select maximum. Okay, 1 second. Let me name this as from CT2. Okay. Okay, this has to be AVG cell, as I've named it as AVG cell. Okay. See, the answer is over here. What my query was, I was trying to find maximum average salary in department. So basically, first I had to find all the average salaries, and in those average salaries I wanted the maximum salary. So my question was something like this. 1 second. If you simply execute this, you will have all the department IDs and their average sale, but I wanted the maximum average sale out of it. So for that I use CT, because this will simplify my query. And then if you see the maximum over here is 2591, and that is what we got from our CT. That is what we got from this query. So what this does is, I'll explain it one more time. First I will write my CT with CT2 as select department ID average sales as average sale from employees group by department. So this is giving me 3 rows, and after that I am using this output over here, and over here I am writing select maximum average salary out of it and from CT2. So this will give me maximum average salary. So this is my table employees, which has employee ID, employee name, address, department ID, department name, and the salary of each employee. Let's add the rank function. I will write it and I'll explain you what it means. Okay. So I will write rank over partition by, so let's partition it by department ID. And after that, if you want to give it some order, so I will say order by salary, descending order. Okay. Okay, let's run this. Okay, let's give an, okay, just a second. Oh, sorry. This has to be over here. So this is our output. So let me explain you what this output means. So first we have written select star. So all the columns will be selected. Then we have rank. So these are all the columns, and then we have this column. So this whole expression will be renamed as rank. So this is our rank, and this is the output for this highlighted expression. Okay, so let's understand this. This says rank over partition by department ID, order by salary descent. So let's understand this first. So first we are partitioning the table by department IDs. So we have three department IDs in our table, 1, 2 and 3. So we will partition it in three parts. So this is the first department, second department. So all the departments will get together. Okay. So all the employees in one department will get in one partition. So like this, all the employees in department 1 are here, then all the employees in department 2 are here, and all the employees in department 3 are here. Okay, so this is our first thing, partition by department ID, which we have done the partition. After that, inside the partition, order by salary in descending order. So inside these partition, now we are only considering the first partition, which is department ID 1. So we will only consider this, and we will not care about the rest of the rows. Here and here we have these salaries, and here the salaries will be sorted in descending order. So as you can see, this is the order. So inside the partition, we will order it in the descending order, salary wise. Okay, so this is what we did. Now here we have written rank over this is. Now over here we will give it a rank. Okay, 1, 2, 3. So this is how we have given the rank. Different partition will start with different rank. Now as you can see, our partition number 2, that is department ID 2, starts from here, and here the rank will start from 1. So 1 and 2. Then here again you can see it is 1, 1, 3, 4. Now why is it so? So we are using rank function over here. Here if the values of the two rows are same, so here we are sorting it in this order, in descending order of salary. So as you can see over here, these two employees, Phoebe and Ted, they have the same salaries. So if the values are same, they will have the same rank, and hence here they have the same rank, 1, 1. But in rank, what is different is here after that, instead of using 2, we will use 3. Number 2 is skipped. Why is it skipped? Because we already have two rows over here. So 1, 1, 3, 4. So the number 2 will be skipped. So this is what rank function is. Dense rank function is also same, slightly different. So let me show you all what it is. Just a minute. So the exact same thing, let's just copy. Select star means all the employees will be selected. Now each department, now it will be partition 1, 1, 1, 2, 2, 3, 3, 3. And in rank we have 1, 2, 3, 1, 2, 3. Dense rank is also same, but there is just one difference. Here the number 2 will not be skipped. Here all the numbers will be used. So 1, 2, 3, and if they have the same value, they will have the same rank. So in case of rank function, we were skipping numbers. Okay, in case rank was being repeated, we were skipping numbers, but in dense rank we will not skip any number. Let's see the third ranking function, which is row number. in case of row number, it doesn't care about the rank, or it doesn't care what the value is. No number is skipped, and it will consecutive numbers will be used: 1 2 3 1 2 3 1 2 3 4, like this. So as you can see over here, even though these two were having the same salaries, when we were using the rank and nens rank, they were having the same rank. But in case of row number doesn't care if the value is same or not. It will be 1 2 3 4, like it will just use consecutive numbers: 1 2 3. So whenever someone asks you types of joins, there are obviously four types of joins: left join, right join, inner join, and full outer join. However, I am explaining a few more variants of joins just in a bit, which you can apply to any query that has been asked to you in your interview. That can actually be very helpful to you. So now these are the two tables. So the first table is customers and the second table is orders. The first table, customers, has customer ID, customer name, contact number, and country. Very basic columns. And the second table is orders, order ID, customer ID, and date. So customer ID is the common column between the two tables. So I will be joining these two tables based on this column, customer ID. So as you know, joins is whenever we try to join two or more tables based on few common columns. So in this case, our common column is customer ID, so that I will be using for joining. Now first I will show you all what is inner join. So inner join is the easiest one. So inner join means whatever columns are common between the two. Select C dot customer ID, O dot order ID, C dot country. So these are the columns that I want to select, and these are the two tables. From customer C, join orders O on whatever column you want to join them on. So what is the common column between the two? Customer ID. So on C dot cust ID is equal to O dot cust ID. So these are the common columns, and since I've just written join, it will just do inner join. Had I written left join or right join, then it would have done left join or right join accordingly. But here it's just inner join. So here what is going to happen is just the common columns, the common customer IDs between the two tables will be printed. So in this case, 101 is not over here, 102 is here, so 102 will be printed, and then 103 is also over here, so 103 will also be printed. 104 is not in the second table, so it will not be printed, and it's done. So only 102 and 103 will be printed, so that is my output. And order ID and country accordingly, like the respective order ID and country will be printed. This is the output for inner join. Let's move on to left joins: left inclusive join and left exclusive join. Left inclusive join means all the values, all the records from the left table will be a part of our result. Along with that, all the rows that are matching with our table number 2, table B, will be the part of our result. Now left exclusive join means all the rows, all the records from the table 1 that are not part of table 2. So all the records that are absent in the table 2 will be the part of our output. Now let's see an example. So this is the same table, customers table, orders table. Now left inclusive and left exclusive. We all have already seen left join, which is very basic. Select C dot customer ID, O dot order ID, C dot country, and I have added one more column over here, O dot cust ID. I know I have already selected C dot cust ID, but I want to select O dot cust ID also, so that I can explain you left exclusive join. From customer C, left join, orders O, very basic syntax. So this, when we write left join, it will do left join on what is the column name, C dot cust ID and O dot cust ID. Now what will this do? It will take all the values from the left table, but also the ones that match with the second table. So what were the values that were matching? 102 and 103. So 102 and 103, all the values from the table 1 will be part of output. So if you see the output, all the values from table 1 are part of the output: 101, 102, 103, 104 also. But 102 and 103, since they were matching, since we found 102 and 103 even in the table 2, even in orders, we have other values also. So we have the value for the column order ID and cust ID. So this is going to be our output. Okay, so as you can see, for all those columns where we do not have a matching customer ID in table orders, the value will be null. So as you can see, for 101 and 104, since 101 and 104 not in our table 2 in our table orders, our columns will be null. So order ID and cust ID will be null. Okay, don't see this. This is the output of left exclusive. I should put left exclusive, and this is the output of left inclusive. Now, what is left exclusive join? In left exclusive, there is just one more condition over here. The exact same query, but after that I've written where o.cust id is null. So wherever, see, so this was the output. This was the output. This was the initial output. But wherever o.cust id is null, those rows are going to be the output of this particular query. The output is going to be this. So where is o.cust id null? This and this. So the output is 101 and 104. So 101 and 104 and whatever are the matching values. So country, USA and Canada. So this will be our output. Left exclusive means all the rows that are part of table 1 but are not part of table 2. So in this case 102 and 103 are part of table 2. So that will not be a part of our output for left exclusive join. So only 101 and 104 will be our output, and that is our output. So this is what left inclusive and left exclusive joins are. Similarly, we can write queries for right inclusive and right exclusive joins. Now let's move on to right inclusive and right exclusive joins. Right inclusive join means all the brackets from the right table will be a part of the result. Along with that, all the matching records from table number 1 will also be a part of our result. Now right exclusive means all the records from the table 2 that are absent from table number 1 will be the part of our result. See an example for right inclusive and right exclusive join. It's the exact same as left join, so I'm not going to go in detail. Now full outer inclusive join is a combination of left join and right join. Full outer exclusive join is just the opposite of inner join, as you can see from the diagram itself that they are exactly the opposite of each other. So full outer exclusive join means all the records that are not present in either of the two tables. What I mean by that is all the records from the table A that are not a part of B, and all the records from table B which are not part of A. So anything that is matching between the two tables will be not a part of our result set. Let's check out an example on full outer inclusive and full outer exclusive joins. The same table, customers and orders, and this will be our query. For full outer inclusive join, I'm using the same query, but over here I have written full outer join. So from customer C, full outer join, orders O on whatever the common column is. So on C.cust id is equal to O.cust id. For full outer exclusive join, the exact same thing, and then I have added a where clause where C.cust id is null or O.cust id is null. Now let's check out the output for this. Now full outer inclusive join, it will be a combination of left join and right join. Okay, so all the values from the left table and all the values from the right table, and whatever is matching will be the part of our result. So all the customer IDs from table 1, so 101, 102, 103, 104. All the customer IDs from table 2, 102, 103, 105, 106, 107. This will be our output, and whatever is matching, whatever order ID is matching from table number 2, 1, 2, 3, 4, 5. Then whatever country is matching from table number 1, that will be written over, and rest everything will be null. For full outer exclusive join, there is a where clause where customer ID, C dot customer ID or O dot customer ID is null. So wherever it's null, this, this. So these five values will be our output. As you can see, 101, 104, 105, 106, 107. So all the records that are not matching between the two tables. Basically everything other than 102 and 103. And if you remember in inner join, 102 and 103 came in the output. So full outer exclusive join is exact opposite of inner join. All the records that are not matching will be the part of this result set. So this is full outer exclusive join. Okay. So this is our output: employee ID, employee name, age, country. Now, for example, I want to categorize the data. I want to print wherever the age is less than 18 as youth, and wherever age is less than 60 as adults, and greater than 60 would be seniors. I want to show that in my output. So what will I do? In that case, we can use cases. So let's begin. I can write over here employee ID. We are selecting employee ID and age, and now we have to categorize data into youth, adult, and senior. For that, we will use case. Case, and when age is less than 18, then youth. Case when age is less than 60, then adult. Then case when, or sorry, also here, we don't need to write case again. We just need to write when. And then over here, we can write else, senior. And we also have to end it. We have to write end over here. So this is where it ends, this is where the case statement starts, this is where it ends, and we will give it an alias. Let's run it. And this is our output. So these are our employees: 1, 2, 3, 4, 5, 6, 7, 8. These are their ages. Let's see if we have got the right output. So for 35, the age type is adult, correct. For 16, it is youth. For 26, it is adult. 32, adult. 66, senior, correct. 12, youth. 22, adult. So it is correct. 67, senior, correct. So we got the right output. Now, I want to group it by country. Like in each country, how many adults are there? In each country, how many youths are there? How many seniors are there in each country? Let's find that out. So I will also add country over here. And since we are grouping it, we do not need employee ID or age. So country, and then I will write it group by country. This is incorrect because we need to find the number of adults, the number of seniors, the number of youths. The number means we need count means aggregate function, so we need to use aggregate functions for this. So what we're going to do is we're going to write over here count, and whenever we use aggregate functions we need to use group by. So count, this is our case statement, and group by country, and then when we run it, this is what we get. But again, this is incorrect because we also need to print the age type. And we also need to group it by age type. Canada has one adult, Canada has one senior, Mexico has one senior, Mexico has one youth, USA has 3 adults, USA has one youth. So this is our output. We need to group age type also, otherwise they would have grouped it all together. We have to group it by age type, we have to group it by country, and then we just have to count those. So we have counted it. We also need to print the age type so that we can see it in our output. So this is our desired output. So in scenarios where you have to categorize data into, say, something like this, youth, adult, senior, and then you also have to aggregate it, you have to find the sum, or you have to find the count or average or something. So this is how you can do it. You can use case statements and aggregate functions together. Before your SQL interview, you should definitely revise the most asked common SQL queries.